Hello friends, today we will see perpendicular axis theorem. If Ixx and Iyy be the moment of inertia of plane section about two perpendicular axes meeting at point O, the moment of inertia Izz about the axis Zz perpendicular to the plane and passing through the intersection of Ixx and Iyy is given by Izz is equal to Ixx plus Iyy. For that, consider a lamina and as point O, consider a point P into the space and its coordinates from y axis is x and from x axis it is y. OP, distance OP is denoted by r, which is perpendicular from the z axis. These three axes are mutually perpendicular to each other. Suppose we consider into the space x axis, y axis and z axis are seems to be like this. From geometry of the figure we have r square is equal to x square plus y square. Say equation number 1. Also we have Ixs is equal to dA into y square and Iyy is equal to dA into x square. dA is area of small element and y square is the distance from concerned x axis and x is the distance from concerned y axis. Say equation number 2 and 3. Similarly, Izz is equal to dA into r square is equal to dA into x square plus y square. Just expand this, x square into dA plus y square into dA. Therefore, from equation 2 and 3, dA into y square is Ixx and from equation 3, dA into x square is Iyy. Therefore, Izz is equal to Ixx plus Iyy. Hence proved. Now we will see theorem of parallel axis. The theorem of parallel axis is given by IAB is equal to Ig plus AH square. The statement for parallel axis is if the moment of inertia of a plane area about an axis through its center of gravity is denoted by Ig, then moment of inertia of the area about any other axis AB parallel to the first and at a distance of h from the center of gravity is given by IAB is equal to Ig plus AH square. For that, consider a circle whose center of gravity is denoted by G, the reference axis as AB, whose height from the CG is h. Consider a strip of area dA and the distance from CG up to the strip is denoted by y and the height of CG and AB axis is h. Then we have Ig is equal to dA into y square, since moment of inertia is product of area into y square. Now, let us consider IAB, moment of inertia along AB axis. So, is it not summation of this area? Therefore, it is summation of dA into the distance with reference to AB axis from the strip is y plus h. That is why it is y plus h bracket square is equal to summation of dA into, expand this particular term, y square plus 2 times yh plus h square is equal to y square into summation of y square into dA plus 2 times yh into dA plus summation of dA into h square. Summation of dA into y square is given by Ig from equation 1. Therefore, Ig plus this particular term equals to 0 plus summation of dA into h square is a into h square. Summation of dA will be obviously a and h square as it is. Therefore, IAB is equal to Ig plus AH square. Hence proved. Since summation of YH into dA, it becomes 0. Why is it so? Because it is along the center of gravity. That is why this distance becomes 0. Otherwise, suppose as such we move y and h, as once we go up and down, obviously at AB axis it becomes 0. That is why summation of 2YH into dA becomes 0. Hence, we proved IAB is equal to Ig plus AH square. Thank you.